Epic fail. Alright, what's going on here? What's going on here? Why is my graphics all messed up? Oh. No screen, no wallpaper. No idea what's going on over here. Oh. Why is the transition screen not working right? Oh, there it is. If I go here. Alright, I need to go to this camera here. Nope. This camera. Edit. Properties. Nope. Cancel. Right click. Transform. Edit transform. Nope. Alright, that'll work. Ah! Wrong button. What did I just do? No! No! Fit the screen. There we go. Move that over there. Do 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 Alright, we'll start some music here. Listen to some music for a little bit. Wait for everyone to pile in. Let's switch to, here we go, let's go with this guy. Alright, let's see here. Hopefully everyone can hear me okay. Let's see if we can get a little stereo sound going on here. Check my phone. My phone is telling me I need to get up and get moving. So what I am going to do is this. Copy this link. It's the infinite window. Alright, we'll get a drink. Nobody's here yet. Let me see. If you hear, forever speak your piece. I'll be right back. Get myself some water. Bueller. Alright, well. I'm going to chill out for another 5-10 minutes. And I'm going to quit. Alright, so what we got here is a Stern Whitestar CPU board. It is out of the Grand Prix arcade pinball machine. And the issue we have is it just reboots. So this is what it does. As you can see, it just keeps rebooting. This has been fixed, but for demo purposes, I have it set up to, hey man, just started. So I'm going to go through a walkthrough on my repair of a pinball CPU board from start to finish. I'm going to see if I can do it in 2 hours. It's already been fixed. It's probably done about 4 hours on the, already done about 4 hours on it, and I have since finished fixing it. And I'm going to go through soup to nuts from beginning to end. So when we got the board, I plugged it on the bench, hooked it up, and this is basically what we were getting. It would boot, the CPU boots up, the sound section boots up, but this is all you would get. So the person who sent it in posted on Pinside. They're like, oh, it's watchdogging, it's doing watchdog resets, so forth and so on. So, wish I had this. I need to create another view with my face here and that face there. So what I can do is just slide my face over here and look at the camera this way. So, you hit reset. This is what it just kept doing that. So what I did was I inspected the board. I saw some corrosion in the EEPROM socket, which I didn't clean until I put it on the bench for the stream. So oh, it's just this socket, because I pushed on the socket, it started working. So I cleaned that socket, and then after I cleaned the socket, put the EEPROM in, or the RAM in, we still got this. Which wasn't very much fun. So then I pulled out the Fluke troubleshooter here. I wanted to make sure I could use it to test the RAM. So using this, I was able to test the RAM. RAM was fine. Nothing wrong with the RAM. I was able to jumper the coin door, verify the coin door circuit worked. No problem. I used the logic probe, didn't see any rebooting, it wasn't resetting, it was just stuck in a software loop. So then I'm like, well, maybe there's something wrong with the game code. It has a really old version of the CPU code. I updated it to the latest version. Still doing the same thing. Couldn't figure it out. So what I decided to do was hook up my logic analyzer, which is what all these crazy wires are here. Monitoring the address bus, the data bus, and a couple other lines. This is my new logic analyzer I just got. It's new to me, but it's actually pretty old. It's about a 15-year-old logic analyzer, but it runs Windows, and the software that I have installed on it from Agilent is less than 4 years old. So it's actually a relatively new piece of hardware, but for what I need it for, it is super overkill, but works great. So it'll do everything I need to do. So the first step was I wanted to verify that it just wasn't reading the code wrong on the EEPROM. So that was another nightmare, because the EEPROM is actually bigger than the address space of the CPU. So you can't just use the Fluke to check the EEPROM in its entirety. You have to chop it all up. But you can't just chop it all up, because the address space overlaps. So we'll go back over to the PC. So we're going to go over here, and we'll go back to desktop view, and we're going to switch over to page 169. So on 169, so 169, here is the EEPROM right here. Most Whitestar games do not have 27040s in it. They have 2710s, so two of these address lines aren't used. It's only X0, X1, and X2. These address lines are controlled by this MUX right here, the 74LS374. This 74 LS374 is controlled by address 15 on the address bus, which does not go to the EEPROM. Address 14 and 15 do not go to this EEPROM. They actually go to the PAL 16V8, which does address decoding. So as you can see, address 13, 14, 15 go into this. And then this basically is in charge of selecting the ROM, the RAM, I/O port, the sound port, the sound strobe, I/O strobe, and then it has this XA0, which is weird because there's XA0 here, and there's also an XA0 up here. Well, later to find out, after doing some reverse, so there was a guy that posted this hacking the Sega Whitestar pinball, and he goes about talking about how he reverse engineered it, and he used a little Arduino to figure out the address space, and he reverse engineered the PAL. Well, unfortunately, his logic is wrong. ROM CS is not right, and XAO is actually an output pin. It is also used as an input pin for the I/O port. So it is a bidirect. So this port is used both ways. It is used as an input, and it is used as an output. So this is the memory map he came up with, which for the most part it is correct. The only part that's kind of misconfusing is this part right here. 4000 to 7FF is ROM, but it is the bank select ROM. 8000 to BFF and C1000 to FFF is actually that address range on the EEPROM no matter what. It is the last 16K of the EEPROM. It is not bank select. It is always there. It is always addressed. It never has to go anywhere. So whenever the CPU is accessing anything in that byte range, that will actually change the address pins to go to that range, and the PAL chip is actually in charge of that. This chip will change the XO address, and it'll basically remaps and goes there. Took me a while to figure that out because this guy that did this reverse engineer didn't quite get the logic right, so that took me a little bit longer to figure out, which was probably the hardest thing for me to do. So this goes in here, controls that. So what then I had to do is I had to then split up the game code into several blocks. So this is basically bank select 0, bank select 1, bank select 2, bank select 3 is here, 4, 5, 6, 6, and 7. So those are the addresses. So then what I did was I took this, I generated my fluke signatures using my website, romidentcoinoutflorida.com, which gave me the ID, the signature codes. I then was able to run the fluke signature process and give me the signatures. I didn't save the file, but I also wrote the first 16 bits of each address so I could confirm that after I did a bank select, it had the right one. And bank select is controlled by address 3200, which conveniently enough, this guy did get that right. So when you write a value to address 3200, it will change the bank select addresses on this chip. So the only ports, so this is what the bank select math looks like. Basically 000 is this part of the ROM. So if it had a 27010 in it, this would be the value, and these are the actual bank select byte values. The reason why it is a high order bit is because if you look at the schematic, they don't use D6, D7, and D8, or D6 and D7. It's not used. It's not. So you generally just write a 1 to it and not a 0 because it's actually easier. I don't know why. That's just the way to do it. Just evil programmers. So that writes to this. I was able to verify. So after figuring all this out, I was able to verify, no problem. ROM code is correct. I can read the ROM. I also checked some of the I/O space. I checked the. Thanks for the follow. So I also checked all these address spaces. So the 68,000 or the 6800 CPU, the 6502, 6800, they do not have an I/O address port. So all of your I/O is actually memory mapped. So there's not a dedicated I/O interface. So if you need to access like a keyboard or a dip switch, it's actually just a memory address. So I verified as much as I could. I actually verified the plasma port for the display. I had no problem with all the ports. Everything worked perfectly fine. Here's the actual I/O port for the display. All the pins worked. Everything was working fine. It still was getting a reset. The fun thing is the story is the ending of the story is the best part. So after that, then I launched this cool program I got here. So the logic analyzer is hooked up behind me. It is running. So we're going to go into the cool logic analyzer, which is convenient because it runs right on my desktop. I don't have to mess with the little tiny interface. So I actually can work on it directly from here. For some reason, there we go, connect. So with this thing, I can then set up all the ports. I can look at ports. I can check stuff. I can look at addresses. I already have this configured, so I'll just load this up. So I basically have my memory address map set up. Reason pod 1 is not being used for my address bus is because bin 10 is not working, which I think I have a bad pod cable, which I might have pinched it, or it's just not plugged in all the way, so I just switched over to the other pod. I got plenty of ports. So basically, this is the 16 bits of data, or address. I'm using pod 2, several of the pins for data, and then I basically just been going through, checking and picking all the different pins, like reset pin, read write, valid memory address, PL, and I even got to the point where I had to put ROM on here. And then I set up the sampling, blah, blah, blah. Trigger was actually probably the most trickiest thing to set up. So basically what we're doing is we're going to check for, this is where I was checking for different addresses. So right now we don't care about any of these. And all I wanted to do is, okay, whenever VMA is high, which basically stands for there's a valid memory address on the bus. If RW is high, which basically says I'm reading the bus, and chip select is on the falling edge, which basically says I want to read the ROM, so that the ROM's going to output data. Go to the next step. The next step is then wait for the rising edge of PL reset. PL reset is usually low. It goes high to reset the plasma controller. And then I basically just hit the play button, or the loop, and then it's basically just going to keep looping through the code. And so this is what we're looking at here now, is we're looking at the point of code that is causing the display to actually reset. I will push the address bus down so you don't see it. So there is the port to reset to the plasma display. And then there is, so if we go back a couple spots, you can see in address where it is actually getting to it. A11F, A120, A121. Basically, this is basically clear, address 3601, and then it loads 3601, and then it writes 0 to that port, which is right here. So 3601 gets loaded, and then it writes 00. And there is the reset. It's not all quite synced up right because I am not reading the bus properly. That goes back to E and Q and not being in the exact right spots. So, and the 6809 does not generate E and Q. It is generated on the outside of the CPU on a 6809. It is provided to it. It does not have it does not have phase 1 and phase 2, or phase 0 and phase 1 clocking. So the 6809's CPU is driven from the sound section on the newer Whitestar board. So there's a 24 megahertz crystal, which is divided down and then fed into this chip. So as you can tell, I'm actually gathering a lot of data. And this is only 512K worth of data. So I probably only really needed maybe 10K of data. So again, this gives us this address that we're looking at before it does the reset. So then the next trick was to figure out how to decompile bank selected ROM. So the good news is after figuring out that the block 8000 through FFF, the top half of the 27C101, is always mapped to that address space and has never changed. It made this a lot easier because then I can just run a simple 6809 disassembler on the top 16K, which then gives me this file, which I don't know, not that file. I think I still have it open. Yep, I still have it open. So here is this file, and basically here is the block of, oh, where did my comments go? I had written comments in here. Well, that's a stinker. I didn't save my work. I didn't save my work, guys. I have failed. Anywho, let's just do this over again. Let's see here. Find 3601. Find all documents. Oh, there it is. It is in here. So that was a different section of code I was looking at. So LD, so basically what I figured out was it is actually trying to read this address. I know it, I was looking over here. This is trying to get the status value, this 3500, I don't remember what it was, but basically the end of the story is here. I figured out where the code was. It clearly was trying to read data from the plasma display. I then went over to the board and I'm like, you know what? Let me just reseat the plasma connector. And after farting with the plasma connector like 3 or 4 times, this is what happens. It starts working. I saved it. I checked every other header, but I didn't check this one pin. I don't know if you can see it. That one pin is about as black as the casing. And basically that is the busy pin to the CPU to tell the CPU that the plasma display is busy doing something. And then there's a counter that basically counts down and waits for this busy signal to go hot or go low. It never goes low, so then it resets it. So I replaced the header, and I fixed it, and now it's done. So I spent 6 hours doing all this because I didn't check the pin header for corrosion. The CPU had this, the RAM socket had corrosion. I replaced it, but I didn't think to check the connector going to the plasma display. So the moral of the story is, if you see a White Dog machine and it is rebooting, check the pin headers. Namely the plasma display. The game will not boot without a plasma display plugged in. And if it can't write to the I/O board, the I/O board will also reset this board. This one, the I/O connector is good, but the other board the same customer sent in is also having a reboot issue, but this one is actually being caused by the I/O board. And reviewing the connector, there is 3 or 4 pins on this connector that are also corroded, so I am going to replace that connector. And I'm also going to clean up some of the work on the back side of this board. I'll do that off stream, but this one I already tested okay, and we can go into system test on this one, and we can listen to some cool music. We'll turn the volume up here. Let's do this. Let's go out. Quit. Let's give it some volume. Do a ball search. Thank you for doing a ball search. It's trying to find a ball. Can't find any balls. Doesn't know where the balls are. Wait for it to finish its ball search. Yeah, it was a... It's actually... So, I learned a lot with this because I really learned how to use this logic analyzer effectively. That was probably the most enjoyable part. Now that I've actually used the logic analyzer effectively, I will probably be using it a lot more, because it takes this logic probe, which is great and all, but it's just one bit. An oscilloscope's great. I have an oscilloscope, the MSO 1104, the Rigel. It's fully loaded. I get the fully loaded options on it. It's got a 16-channel logic analyzer on it, but this has a 16-channel data bus, or 16-channel address bus. It also has 8 data pins. It has a bunch of status pins. I'm using 3 16-bit pods to hook this up. Can't use any. There's not any modern tools that you can easily get that is relatively cheap to do this. So, cool thing is I picked up the 1680 here. I picked this unit up off of eBay. I literally paid $100 for it. Yes, $100. It didn't work. Well, lo and behold, it didn't work because I have no idea why, but when I got it, it worked. It turned on. The video picture showed a busted screen. I don't know what happened. All the serial numbers matched. It was giving... It had a sheet with it showing that it was fixed by Agilent, and I guess it never went back to the customer, or it went in and no one actually checked it, but I ended up installing a new motherboard in it, installing Windows 7, and it works really good. It boots up really fast, but it's only the 1680A module, which only does 512K RAM. I then scored another 1680AD, which is the 2 megabit RAM version. So it's the same model, but it's got 4 times the amount of memory. And then I also had, and so I'm like, oh, I'm really liking this model 16808 series. So then I bought a 16903A that was also non-functional and broken, and I have since fixed it. Sadly enough, I can't change out the motherboard in a 16903 series because the firmware or the software that controls the logic analyzer looks for a BIOS signature in the BIOS on the main board. So if it's not using an authentic Agilent power motherboard, it will not load the software. This is not the case on this unit, because this unit here is actually they make a standalone version called the 1691, 1692, and 1693, which is about this big and just connects to a PC over a FireWire cable. Well, that's basically what this is. This has a PC in the front. This is a PC display. It has a keyboard interface that hooks up to the logic analyzer, and it talks to it via FireWire. So the PC motherboard is talking to the logic analyzer or FireWire. So the software doesn't have a BIOS restriction for the motherboard because it doesn't see it as a 16900 series. It's really confusing. But anyways, back to where I was. We got squirreled away. I'm going to crank up the sound on this. Oh, that's credits. Alright. That's credits. That's volume down. That's service menu. I don't want service menu. That's gonna search for balls again. All right, what's the pen for? Oh, pull out the trusty service manual. That's the other thing I don't like about Stern Pinball is they don't tell you which pin. They don't have the fancy switch matrix. Like, this dedicated pin goes to this. This dedicated pin goes to that. Nope, sorry. You gotta go find it in the book, find it where they're drawing paintings and something, find the wiring diagrams. I sit here and thumb through this for 4 hours. When they show you this, well, actually no, it is right here in the back. Left flipper button, so it's begin test, service credit, volume, flipper, EOS, flipper. How do I turn the volume on? It's not service credit. So that's a flipper button. That's volume down. There we go. Alright, so volume works. We're going to service. We just want to test the audio. So sound processor working. Everything's working, so I'll just button this all up, and this one's good to go. I'm going to install a NVRAM module in it. These are not available anywhere to make or buy, but I make them myself. This is a Cirrus Logic CY08 and a little SOP adapter. It is pin for pin compatible for a 6116 or 8K EEPROM chip or RAM chip. So I'll pull out the SRAM that's in here. I will then install this. Make sure it's working. That's why the sound had to be reset, because I had set the sound, but since I turned it off and turned it back on, that's why it's dead. So that's it. That was the fix of this wonderful board. Yeah, so if you unhook, well, the interesting thing is
this is what I also learned is if you unhook the display, it still runs. I hit reset. The board is actually resetting. And now it's going to do a ball search. We'll wait for the ball search to finish. It should be, so if I plug this in, it should update to be in the ball search. So it actually is running. So if I unplug this, it's not going into a reboot. It's just the logic that drives the display is rebooting. Plug it back in, and it should be probably at the. It's at that same. So if I go into music test, turn the volume up first. I go into music test. And I unplug the display. It's not rebooting the whole game. I can actually go to the next test. So it's still running its normal code, and it's causing a display reset. So if I plug the connector in just barely like it was doing earlier, I can get it to display the same goofy. So that's what I was doing earlier, rebooting, but you can still see it's still in that test, and it's still in the code. Everything's still working. It's just the display's resetting. So I kind of knew that the game was running, but for some reason it kept rebooting the plasma display, and that is because it's trying to read a status pin from the display before it sends the next command to the display to update the display. So the only thing I can think of is they put some kind of logic in there saying, hey, if you're going to display an animation, check to see if the animation is done displaying before it goes to send another animation to the display. I'm probably what I'm going to do is I have a spare Whitestar board. I'm actually going to probably document this port and create a little... I've also learned how to write my own code to run on a Whitestar board. So I'm going to write some fancy code to write stuff to a display and maybe make a very expensive clock using an actual DMD display with probably some game code in it. Maybe I'll put Simpsons on a board, Simpsons Pinball Party, and have the display update and hook it to my doorbell. So when you walk in, it says some, figure out one of the sound effects to play or something. But that's it. That's fixing this board in a nutshell. And if anybody has any questions, yeah, run DMD 2.0. It's just gonna be a little more expensive. It's gonna be $500 for Run DMD. But yeah, because the Run DMD talks directly to the actual plasma display. And I'm just going to try to document the protocol going to the actual regular display using the actual Stern display controller, which will be an interesting way of figuring things out. That, and I should probably make a little my own custom diag ROM that I can use that I can put in there, because you can actually run code without needing the RAM. So the way the 6809 works is, I mean, you technically could write, stack pointer is internal, it's a register. So as long as I'm not pushing anything to this, like pushing anything to a stack or doing any zero page RAM, you theoretically could run a bunch of code directly from the, and as you can see, it's still, my logic analyzer is still running, but it's waiting for a trigger because it's no longer resetting the plasma display. So that was, thanks for the follow. Oh, well, thanks for the donation. Appreciate that. So the NV RAM is a Cypress CY 16W08 chip. So you can order these. So the chip isn't made anymore. It is no longer available, but there is. Where is it hiding at? I'm just playing with this chip. Where did I put it? I don't know where I put it. I had it in my hand. I found a supplier in China who has them, so I ended up ordering a bunch of them today. I ordered 50 of them. Hopefully they all work. And then you buy these little SOP 28 to DIP 8 adapters, which I bought some of these to adapt some actual SOC 26s. So these are SOC 26s or 24s, and I used the SOC 28, but the outer 4 pins aren't used. But I had bought some of these, and I actually have some more, but I found a supplier for these, and they're like $1 each. The chips are $1 each. So they can put them together for about $5, and I think there was a guy selling them for $20, but no one seems to have them anymore. So I ordered a bunch more chips. I'll build some and test them. Probably sell them for $10 or something like that. I don't know. Might have to make it worth my while. I also figured out how to write. Oh, here it is. I also figured out how to write. I found the code for the. Did I read that right? $35.99. Did I comment it? I don't know where that's even going. It's not going to me. Yeah, you're not donating it to me. I don't know what you're doing. I don't know what that is. No idea. Yeah, someone's just typing in. Funny. Alright, I think you're a bot. Alright, so Salvo the King 31 is being funny. He's a bot, obviously. Yeah, so I'll probably make some of those. Also, I don't know, remember a couple of years ago, someone kept blowing these out, and these are $20 a pop. These are the PAL chips, U213. I am now able to program these. I have the code for them, and the code apparently works. I did not develop the code for them, someone else did, but the cool thing is I can do those. I can do the flash chips now. So only the last one is the CPLD, and once I do the CPLD, I will be done. Okay, Salvo, I don't know what you're doing over here, but I think you're gonna get timed out, buddy. Click you. Timed out. Bye-bye. Fun times. Yeah, I was like, what is this? Like random text of donate. Like, dude, don't make no sense. Then he's like joining and leaving and joining and leaving. I'm like, what? Yeah, very weird. So yeah, fun times. I got some MCR boards that'll be next. Those will be fun. Some Tron arcade boards. I got, I think, a couple of them. I got a food fight. I have one food fight left I need to fix for Timothy C. I fixed all the other ones and gave them to him, but I have one left that I need to fix, and it's got a random character graphics showing up on the screen. So, which would be cool. I can then use this on it, and hopefully I have two food fight boards. One that works, one that doesn't work. So I'll be able to do a comparison side by side and see if I can figure out the difference between them. It just sucks if you have to probe one board and then probe another board, and then look at the data between them. That'll be fun. But yeah, this is that chip, the NVRAM chip. It's hard to see. I will show you what one looks like online. The guy that used to sell them. NVRAM. Pinball. So this is basically the same thing. It's a 6264 adapter. So this guy used to sell them. I don't think he doesn't sell them anymore. Unfortunately, this product is no longer available. He was charging $20. I think what's his name in Illinois has them as well. They were $20. He doesn't sell them either anymore. They're out of stock. Apparently nobody has them. The only one that is available is the AnyPen version, which is this version, which is basically using the same chip, but it's using the new branded Ramtron, which is basically the same exact chip. There's the part number FM16W08. It is available from China. You can get them. But if you order 100 of them, that doesn't cost you anything more shipping. If you want to sit on 100 of them. I also ordered some hard to find flash chips as well. But yeah, the AnyPen has dip switches to change it between a 6264 and a 6116, which is just one pin difference. And then it supports a 5101. If you're using the 5101, and that gets tricky because you actually have to change the pins around to get it to work in a 5101. So that's what the extra switches are for. I'm like, I'm not worried about 5101. So that's it. That's all we got. That's all she wrote. It's fully working now. So I'm gonna tear down my rig, and first I'm gonna do is plug this chip in and make sure it still works. So we'll turn the board off, and I can do that from my desk, because everything in this room is controlled by IP. So we'll just go ahead and swap this out ever so carefully. With my trusty chip puller. I'm just gotta make sure I put pin 1 down, which is completely oxymoronic, but that's just how this board was designed. Pin is down, so we'll turn it on, and let's do a ball search. Sorry about the flicker. That's what happens when you're using a 60 frames per second camera, and this is running slower, or faster, or slower, faster, or slower. I don't know. But, yeah. Got some interlacing, but it's It's using an actual 1080p 60 frames a second overhead camera shooting down. Then I have over here on this camera over here facing this gear here is a GoPro 4 Plus, again running 1080p going into cam links. Cam links are then running over to the upper PC. I'm also using some Logitech 930 cameras, one there, one over there. I have another camera that I had set up way over there, behind me, up in the corner. I don't, can't see it. Over there. It covered the whole side of the room, but it's an IP camera and it was delayed. Didn't work very well. So, one of my goals is to do screen captures off the MSO 1104. So I'm going to set a button up on my Stream Deck. I'll hit a button. It'll capture whatever's up on the Logic Analyzer or on the scope, and then flash it up on the stream for like 5 seconds. But haven't quite figured out how to do that yet. Apparently, I got to do some reverse engineering of the protocol. I found some stuff on the net. Apparently, it doesn't work with this version scope. This scope does have it. I can launch the MSO Rigo software, and it will use it in the Ultravision software. But the problem is from my understanding, is the Ultravision software you have to go hit a button to capture the screen, or it's not very intuitive. Apparently, you can just tell it to do a screen capture, and it'll grab it and put it in a PNG and send it over the network. So let's just get the sound, adjust the sound, bring it up. Oh, those are credits. I don't want the service menu. Quit. That was ball search. There's no balls. You have no balls, sir. You have no balls. No balls. Stop looking for them. Yeah, that was the other fun thing is I do have a Arduino I can hook up to the I/O board and control the I/O board and do full testing with the I/O board without this board. So I can test all the inputs and everything. Alright, so this one's the down run. Alright, 13 credits. I am going to turn it off. I turned up the volume. And I turn it back on. It should remember the volume setting, because that is a persistence. Well, actually I could set the free play. I don't think I can get in service while it's doing this. Yep. Oh, yep. Remember the volume. So we'll go in here to adjustments. I'll go into feature adjustments. Apparently it is not in... No, I don't want to quit. It is in standard. Replay. Then I go to the next setting. Alright. That should be that. So if I hit reset, well, resetting gonna work. If I turn it off and do the old manual way. Got no battery. So what I'm gonna do, I'm gonna go ahead and unhook all this mess here because I don't need it anymore. I can't see the chat window. No one's saying anything. You are welcome, sir. Anybody has any questions, feel free to ask any questions. I have absolutely no issues with answering them. This is probably the coolest thing is this adapter right here. It allows me to hook up the Fluke troubleshooter and probe all the address pins. And it gives me a good ground reference. I may end up making an adapter for some CPUs, which I could do is they make a soft touch connector, which has this little connector on it. That's actually 2 pods in a small little connector. So I theoretically could make a little PCB that I could plug this into. Not this style one. I just picked up, like the other one I just got, one of these has this soft touch connector that plugs into here, which then I could just plug that in here, the pods plug into it, and then I would reduce all these crazy fly cables everywhere. So carefully remove all these. Can't just rip them off. You gotta unhook them. And the problem is you're creative when you put them down, but then they start getting a little ornery. Carefully remove all these. One, and then I'll remove all those later. That right there. So yeah, so wherever there was a clip is what I had hooked up. So this cable here only had, I was only using 4 on that, but basically that's how many leads I had hooked up to this board. So you ain't buying your Saley ain't gonna handle those 8 channels. A lot of channels. I used the CPU that was in the board in my tester. That's turned off. Lock it. How about I find a screwdriver that actually fits? Goes back in here. This is the customers. It's back in this. Can leave that on there. Don't need the logic probe anymore. Alright. Spray turns on. The sound section's booting. Doing a ball search. Someone has replaced the PAL chip on this machine. So chips I carry in stock is this chip here. This chip is a $50 replacement from Marco. I carry this chip in stock. I have replaced this chip on a board before. I do have a couple of these that are programmed. I don't have the CPLD code for those. Hopefully someday I can get it, but right now I don't. I can now program this chip. I have the code for that chip. But other than that, this is working good. Looks like it's in free play. I don't know where the start button is. Is the start button a dedicated button? I don't think it is. I think only the flipper buttons and the coin door buttons are. You can test service credit, volume, right, left, EOS. So 206, which is the other one. Yeah, all the other switches are. Unfortunately, the start button, left slingshot, start, coin button, center button, left coin, right coin, shooter lane, ball trough, drop targets. That is all off of the I/O board. No, CN5. No, it's right here. CN5, CN7. Okay, I got this. We got buttons. We got buttons. We can do this. You can press start.
Probably gonna say enter a ball though.
Let's shoot over to not this guy. Don't need that one no more. Need that one no more. And alright, let's do this. Go here. Open this back up. Alright, so last page. Alright, here's our switches. Dedicated switches. Let's go back to desktop view. So left flipper, EOS, not used, volume. Yeah, that's what's confusing. So the volume on this, you gotta hit the one volume button first before you hit the other volume button, or if you hit service credit first. So this is a three button dedicated switch setup. Alright, where's the start button? Start button is CN5 P8 to P3. So P3 to P8. So we go P8 to P3. So CN7 P3. It says free play. So CN7 P3, 1, 2, 3. Right? CN7 PN3 to CN5 P8. So this should go to pin 8. It's probably going to work. It's probably going to say that I need to put, yeah, 4 balls missing. So it did not like me doing that. Like, I want to play. 4 balls missing. So it's missing its balls, so it won't let me play it. So, alright, I'm done. I'm gonna pack this one up. I'm going to, there's nothing to repair on this one. I'm just going to replace this header. It's got some little bit of corrosion on it. So I'm just going to go ahead and replace it. I am going to then clean all this up and probably pull out this PAL chip and fix this cleanup up here. There's some jumper wires put here, so I'm just going to clean this up and then verify this is still working. It does work now. I'm going to double check to make sure it's working before I do that, so I don't screw anything up. This is a Sopranos board, so this one's done. So I think that's it. Well, I was hoping it was going to run longer, but doesn't look like it. So let's find someone to raid or not. Who do we got out here still? We still got Pass Blaster. Who do we want to raid? Pass Blaster. Give me a raid. Give me a raid target. Do 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 do. Alright, I got no raid targets. Nothing in this line of stuff. How about we do this? How about we raid? I don't know. Who do we want to raid? Here we can watch a picture and a picture and a picture. Actually, it doesn't work that way. You can only see one picture. Alright, who are we raiding? Who are we going to raid? This is the moderator panel for a Twitch broadcaster. Oh wait, you don't see this, you see the other screen. Haha. You don't see this evil screen. Okay. Who are we going to raid? 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 Alright. Twitch TV. Let's find somebody. Nope, pause that. And making crafting. Let's see who's in here. What do we got? We have some art people. Building a computer desk. Iron Man model kit. Building an all pink PC. This guy don't have a subject on his thing. A lot of keyboard people. Crochet. Custom fishing rods. All right. Let's go with this guy.